Hey, math friend, it's time for a super cool lesson on the power of the rule of conservation. So, one of the most challenging things that we do in math is regrouping when it comes to subtraction. We also know that there are lots of different ways to solve math problems, and this is one of those that can really help you avoid regrouping. And it's based on this law of conservation, which you're going to learn a lot more about as you get older. So let's practice the law of conservation with a super simple problem just to show you how it works. So here we have 10 minus 7 equals 3. We all know that. We learned that in kindergarten or first grade. Can I make more problems where the answer is still 3? Well, yeah, there's tons of problems where the answer is 3. But let's do it kind of in a systematic way. Let's imagine someone's like, hey, I want you to come up with all the problems in the world where the answer is 3. You'd want to do it in a systematic, logical way so you wouldn't miss anything. What if I take this number and I add 1 to it? What am I going to get? I'm going to get 11. Well, we know that 11 minus 7 is not going to be 3. But what if I took this number and also added 1 to it? Would I get an answer of 3? I sure would. Could I keep doing that? Yeah. Can I add 1 to this number and add 1 to this number? Do I still get 3? You bet I do. Can I try it again? Can I add 1 to this add end and then add 1 to this add end and still get 3? I sure can. Now can I do the opposite way? Could I take away from each add end? Let's try it. So instead of adding 1, I'm going to take away 1. So 10 minus 1 is 9. I'm going to do the same thing to the 7. 7 minus 1 is 6. Is that 3? Sure is. Can I do it again? Yep, still 3. Can I do it again? Oh my gosh, still 3. That's the law of conservation. It says that if we have two numbers that we're adding or subtracting, if we either add or take away the same amount from each one, the difference, that's the space in between the numbers, is going to stay exactly the same. So you're thinking, well, that's kind of a cool party trick. Probably you can go home and show that to a little brother or sister. But how does it help me with huge old 4th grade math problems? We can do it again. We can do the same thing. Okay, so I've got two numbers that I'm going to have to subtract. Obviously, I'm going to have to do some regrouping. I want to try to avoid regrouping at all costs. So what I want to do is I want to keep the distance between the numbers the same, but I want to change the numbers. You can go this way if you want. So I like to try to do that in the smallest and simplest way possible. So I'm going to add 3 to each number. So 782 plus 3 is 785. 457 plus 3 is 460. Now I've created two numbers where the space between them is the same, but they're different numbers. And now, look, I no longer have to regroup. 5 minus nothing, 5. 8 minus 6, 2. 7 minus 4, 3. That was so much easier as a math problem. Now, just to make sure that I got it right, let's do this one the traditional way. So I can't do 2 minus 7. I have to regroup. 12 minus 7 is 5. 7 minus 5 is 2. And 7 minus 4 is 3. Notice they are exactly the same number. Why? Because I did exactly the same thing to each one. Okay, does it work with you in bigger numbers? You better believe it. In fact, it works even better with bigger numbers. This is probably one of the hardest problems to solve if you're using traditional regrouping, right? Because you've got to change all those zeros. What a pain in the brain. Let's not do that. Let's think smarter and use that law of conservation. So what could I turn all those into? Well, I know the biggest digit I can have in a place is 9. How could I quickly turn all of those into a 9? I could subtract 1. So 20,000 becomes 19,999. Well, if I do that to the top number, I have to do it to the bottom number. So 2,257 minus 1 is 2,256. Now I just turned a nightmare of a problem when it comes to regrouping into a super simple problem that has the same difference. 9 minus 6, 3. 9 minus 5, 4. 9 minus 2, 7. 9 minus 2, another 7. And there's our answer. Now, just in case you're like, that can't possibly be that easy. It can't possibly be right. Let's try it traditionally over here. So I'm going to have to come and take a 1 and then turn. A lot of work. All right, 10 minus 7, 3. 9 minus 5, 4. 9 minus 2, 7. 9 minus 2, 7. And 1 minus nothing, 1. We have got ourselves the exact same answer. Wow. Mind blown. So I want you to try this on your exit ticket. I want you to actually solve each problem twice. I want you to try to use the law of conservation. I won't tell you what you're going to add or subtract to each number, but kind of work it out in your head, whatever works well in your head. But then I also want you to do it the traditional way, just to make sure you're getting the right answer. You just have to remember the law of conservation states that whatever we add or subtract to each number has got to be the same. It can be any number, right? As we learned back here with simple numbers, it can be any number, but you have to change both numbers. Good luck. Have fun. Think mathematically, not magically.